Hello. This video is going to cover Unit 4, Part 2, Reflections on the Coordinate Plane. I'm going to be moving pretty quickly through some of this material, so ladies and gentlemen, please read all options first before selecting. Use the pause button if I'm moving too quickly, right, to slow things down. And if you need to, you can rewind or go back and listen again. We're going to start off here by reflecting points and figures over the x-axis. The x-axis is the horizontal axis. So what we're going to do is we're going to reflect points A and B over the x-axis and then the entire triangle CDE over the x-axis. Now, what we want to do is simply count the distance between the point A, which is at -5, -3, and the line, which is the x-axis. It is 1, 2, 3 below. Point A is 3 below the x-axis. Therefore, point A prime, 1, 2, 3, A prime will be 3 units above the axis, right? Both points are equal distances away from the x-axis. A is 3 below, A prime is 3 above. A prime ends up at -5, +3. -7, 0, this is an interesting one. -7, 0 is actually on the line of reflection. So if you think about it, how far away from the line of reflection is point B? Well, it's 0 units away, it's on the line. So it's not going to go above, it's not going to go below. So as a matter of fact, point B and B prime, I'm going to write equals B prime, are actually the same coordinate since this point will not reflect anywhere else since the original point was on the line. -7, 0 remains where it is. Okay, so far we've had pre-image A becomes A prime, B becomes B prime. So now triangle CDE, I'm going to write this down, guys. Triangle CDE is going to map onto, that's kind of how we read this, right? Triangle CDE becomes triangle C prime, D prime, E prime. So let's see where these points go. 8, 6 is all the way over here, up at 6, point C. Now, think about it. It's going to be 6 above, therefore point C prime will then become 6 below. Now, C prime becomes 8, -6. So what I'd like you to notice here is I'm starting to see a pattern, and I want you to see if it continues. -5, -3 became -5, +3. -7, 0 became -7, 0, no change. Okay, I'll come back to that. 8, 6 now became 8, -6. All right, so are you noticing a pattern? Well, let's see what happens with these next 2 points. 10, 2, which is right here, it's 2 above the line of symmetry. So that means point D prime is going to end up 2 below, right? So now this coordinate D prime will end up at 10, -2, right? So I think that pattern is still happening here, right? The x coordinate, 10, is remaining the same. The y coordinate is becoming opposite, right? Even back here, -5 remains the same, but -3 becomes the opposite, right? Negative becomes positive. And finally, we're going to graph point E, which starts at 3, -4, right? Now be careful here. E is 4 units below the x-axis. So where will E prime end up? Well, think about it. If it's 4 below, then E prime is going to end up 4 above. Okay? So now we have reflected all of the points on the triangle. What I'm going to now do is just simply connect C prime, D prime, whoops, and E prime. Okay? Now, since this triangle, the pre-image triangle CDE, was overlapping or was intersecting through the x-axis, so is its image. So here we go. Triangle CDE maps onto or becomes triangle C prime, D prime, E prime. So what we're trying to get to by the time we're done with this is a rule, a shortcut. So x, y, look at all of, I forgot to write this, right? 3, -4 became 3, +4. So the pattern fits, all right? So it works in all of these cases, including this, right? Didn't -7 stay the same? And the opposite of 0 is 0. So the pattern fits all 5 of these points. So basically a nice shortcut will be x remains the same. So therefore I have x here, remains x. However, whatever the y coordinates were became opposite. So now y is going to become the opposite of y, right? I don't want to read that as negative y. I want to read that as the opposite of y. Because if it starts out negative, it's going to become positive. I hope that makes sense. We're going to move on to the next one. Reflecting over the y-axis. Now, I have the y-axis, the vertical axis, highlighted here. So what we're going to do is we're going to take triangle ABC, which has coordinates located here. We're going to take that and we're going to reflect this over the line over the y-axis, excuse me. So now, let's see what happens here. Now again, ladies and gentlemen, we're always going to be equal distances away from the line of reflection. So if C is 1, 2 away from the line of reflection, C prime will be 2 on the other side, right? So I'm going to put prime there. Now let me go put those coordinates. That's 2, comma, 1. Let's see, as we go through here, let's see if we recognize a pattern. Now, A is 1, 2, 3, 4, 5, 6, 7 units to the left of the line of reflection. Therefore, A prime is going to end up 7 units to the right of the line of reflection. So A prime is here. New coordinates are going to be positive 7, comma, negative 2. Positive 7, comma, negative 2. Guys, do you notice a pattern here? What happens to the negative 7? What happens to the negative 2? Well, let's try to get to the last one here. Let's see if you can make a prediction. Where will point B end up? All right. Oh, excuse me. Where will point B prime end up? Well, let's try it. We are 1, 2, 3, 4, 5 away on the left. Therefore, point B prime will end up 1, 2, 3, 4, 5 away on the right. And there's B prime. We're labeling all of our coordinates. All right. I'm going to connect. And you should see a nice mirror image. Pre-image on the left, image on the right. Okay, cool. Alrighty, so now down the bottom, I'm hoping you're noticing a nice pattern here. Okay, so I'm going to take negative 5, 4, which was B, and which is now positive 5, 4. I hope that you notice that each of the x coordinates here have become the opposite sign. Right? Negative 2 stayed the same, 4 stayed the same, 1 stayed the same. But the x coordinates are becoming the opposite. So in summary here, we are going to say that, think about it, the y coordinates will remain the same, so y remains y. But what will I write here for the x? Well, that's going to be opposite x, right? So now to finish up before we move on to the next page, all right, we're going to take triangle ABC, or we took triangle ABC, reflected it over the y-axis, and that is going to become, or map onto, A prime, B prime, C prime. Okay, next page. Okay, so we talked about this in the beginning of class. So we're going to try to reflect over horizontal and vertical lines. So in this case, they want us to reflect over a horizontal line. So draw the line y equals 3, which I've already done. But I want you to think about this, guys. If the line y equals 3 is horizontal, I want to try to describe why that is, okay? Pun intended. So now, if you think about it, the line y equals 3 is here. I'd like to list a few coordinates on that line. So think about it. We have 0, 3. We have, I'm just making them up, right? 5, 3. And then maybe negative 6, 3, right? What do you notice in each of these coordinates? Well, yeah, the y coordinate is 3. Hence, the equation of the line is y equals 3. When is y equal to 3? Always. What can x be? Anything. All right, so let's give it a shot here. Now, the only thing we have to be careful about is sometimes students make a mistake. They might count, say, for example, point G is only 1, 2, 3 away from the x-axis, but we're not reflecting over the x-axis. We're reflecting over the line y equals 3, so I have to keep going. So 1, 2, 3, 4, 5, 6. So G is 6 units below. G prime will be 1, 2, 3, 4, 5, 6 above. All right, so there's G prime, okay? And that's located at negative 5, 9. We're not going to worry today about a rule for these horizontal reflections and vertical reflections on the next page. So now I have H is at negative 7, 0. Be careful. 1, 2, 3 below. So now I'm going to go 1, 2, 3 above. H prime will be there. All right, that's going to be negative 7, 6. Okay, j is 8 comma 6. Here it is. Now be careful. J is above the line y equals 3. So therefore, j prime, think about it, 1, 2, 3 above will now be 1, 2, 3 below, which is now 8 comma 0. All righty. Finally, k is located at 10 comma 12, 10 comma 2. Man, can't talk. So here's 10 comma 2. Now, ladies and gentlemen, it's only 1 below the line. So where will k prime end up? Sure, it's going to end up 1 above it, right? Which will be 10 comma 4. All right, so in summary, all we're going to do is count the distance away from the horizontal line. And let's remember, very, very importantly, that all horizontal lines will look like y equals some number. All right, on to the next page. So now we're going to reflect these points over a vertical line, okay? Again, vertical lines will look like x equals a number. So think about this. If I look at this vertical line, x equals negative 4, let's list a few coordinates on it. So let's see. I have, let's try negative 4, 0. All right, let's go up a little bit. How about negative 4, 10? All right, and then how about negative 4, negative 6? So all of the points on the line x equals negative 4, look, have an x value of negative 4. All right, so it's a vertical line. So here we go. This should go quickly after the last few pages. So what I'm going to do is simply count. All of these 4 points just so happen to be on the left side of the vertical line. So when we reflect it, they will all end up on the right. So n is going to end up 1, 2, 3, 4 to the left. N prime will be 1, 2, 3, 4 to the right, which is at 0, 6. That's n, 0, comma 6. Okay, cool. Next one, p is right here. I'm just going to go down. 1, 2, 3, 4, 5, 6 away. 1, 2, 3, 4, 5, 6 on the right. There's your p prime. M, 1, 2, 3, 1, 2, 3. So there's your m prime. And L is only 1 away on the left. Therefore, where will L prime go? It'll be 1 away from the line on the right. Let's remember that all vertical lines will look like the equation x equals some number. Okay, that brings us to our last 2 ideas here, okay? So far, we've reflected over horizontal and vertical lines. In these last 2 examples, just like we talked about before class, we're going to reflect over 2 different oblique lines. We're going to start off with this oblique line here. Whoops, let me fix that real quick. Right? So we're going to start with this oblique line here. It's a positive line. How do I know? Because, if I was hiking and I start from left to right, we're going to be increasing and going up, right? We read a graph just like a sentence from left to right. Now, after we talked about this earlier on in class today, what is the slope of this line? Good. Well, the slope of this line is up 1, right 1, right? Rise over run. So we usually just say the slope of this line is 1. What is the y-intercept of this line? Well, the y-intercept of this line is 0, right? So even if we wanted to write the equation in slope-intercept form, y equals mx plus b, well, think about it. We would have y equals 0x, oh, I wrote that wrong, my fault. That'll be 1x plus 0, right? And that will simplify, think about it. 1 times x is x, plus 0 is just y equals x. Now, this is an interesting line. There are some coordinates on this line that are very simple to find. 1, 1, 2, 2, 6, 6, 10, 10, negative 4, negative 4. So all of the x's and y's on this line match. All right, let's give this a shot. Now, this is tricky. So what we're going to do first and foremost is literally give you the rule first. So x comma y becomes or maps onto y comma x. So if you notice, we're going to take the original coordinates and swap them. So this rule has one particular part to it. Take your coordinates and just switch their places. So negative 4, negative 2 ends up at negative 2, negative 4. U prime, let's go check it out. So here's u. We want to see u prime is at negative 2, 1, 2, and then down 1, 2, 3, 4. There it is. So there's u prime. I'm going to do something in a few minutes after we get these other points on here. But if you notice, you can see it reflects onto the other side. U was kind of above left, Now u prime is now below right. Okay, let's keep it going. Negative 5 comma 6 is point V. It's up here. That's going to end up, we're going to swap these. That's going to end up at 6 comma negative 5. All right, let's see what happens. Let's go to positive 6 to the right and then down 1, 2, 3, 4, 5. All right, so this is going to be point V prime. And as you can see, again, V was kind of above left of the line. V prime ends up below right of the line. Finally, we have W located at negative 2, 1. Well, ladies and gentlemen, where is W prime going to end up? Well, good job. So it's going to be at 1 comma negative 2. We just swapped the coordinates. Let's go try it. We're going to go to 1 comma negative 2. And that's going to be W prime. All right, now I'm going to do this very quickly, but we said the slope of this line is 1, right? Up 1, right 1. So I'm just going to pick, well, actually I'll do it for all of them, right? I'm going to take my red pen here. I'm going to connect these coordinates from pre-image to image, okay? And if you notice, right, all 3 of those red lines that I just connected, they meet the line at 90 degrees, right? Now just to check this, right, here's what I'm going to do. I'm going to start from U and go to U prime. So that's down 2, right 1. So think about that. Excuse me, down 2, right 2. So down 2, right 2, well, if you think of that slope, down 2, right 2, well, that slope is negative 1. Now, think about it. The line that we just drew had a slope of 1. This line has a slope of negative 1. These two meet at 90 degrees because their slopes are opposite reciprocals. All right, in summary, ladies and gentlemen, how do you apply the rule for the line, or the reflection line, y equals x? What do? We are going to simply swap the coordinates, x for y and y for x, and that brings us to our final page. All right, our last type of reflection. So after the last page, I'm going to speed this up a little bit. This is the line y equals negative x, right? Some coordinates on this line might be, here, check it out. Let's, how about negative 8, 8? Notice they are opposites of one another, right? 0, 0 is also on this line. Now, what's the opposite of 0? 0. How about 2? What's the opposite of 2? Well, that's negative 2. So 2 comma negative 2 is on this line, right? Let's think of what other coordinates could be on this line, right? Yeah, good. 6, negative 6, 8, negative 8, negative 7, 7, etc., etc. So, ladies and gentlemen, the slope of this line is negative 1. All right, it's going down 1, right 1, down 1, right 1, or down 10, right 10, down 10, right 10. The y-intercept of this line is also 0, passes through the origin. So it's basically the same as y equals x, except this is going through the second and fourth quadrant in a downwards fashion. All right, now this rule is a little trickier. Not only do we swap the coordinates, right? Swap x for y and y for x. Notice they changed positions, but we're also going to change their signs. So we read this as x comma y maps onto the opposite of y, comma, the opposite of x. 2 rules. Swap them and change their signs. Okay, here we go. So negative 4, comma, negative 2. So I'm going to swap them and change their signs. If you wanted to, you could change their signs first, right? So I'm going to take this negative 2 and put it in the first position and switch its sign. That's going to become 2. I'm going to take the x coordinate and swap it and put it over here, but change the sign. So now let's see. Negative 4, comma, negative 2 becomes 2, comma, 4. So here's x, right? So now I'm going to move, right? 1, 2, 1, 2, 3, 4. All righty? So there's x prime. Okay, you can see x was over here. It's going to reflect up there to x prime. All right, last two. Y is at negative 5, comma, 6. Well, I'm going to take the 6. I'm going to put it in the first spot, but I'm going to change its sign. That's going to be negative 6, and then swap it and change the sign will become negative 6, 5. So now instead of going, right, instead of going negative 5 and up 6, we're going to go negative 6 and up 5. Boom. So you can kind of see, there we go, just a little reflection, you know, just about 1 unit on each side. Finally, we have negative 2, comma, 1 for z, which is right here. we're going to swap them and change their signs. So where will z prime end up? Well, let's think. Take the 1, put it in the first spot, change its sign. Take the -2, put it in the second spot, change its sign. So that will be -1, comma 2. -1, comma 2. There it is. Not much of a distance here, right? Not much of a reflection. But let's take, for example, the coordinates x and x prime. Now, hopefully, yeah, it should form that right angle. Now, what would we know about the slope of this line of symmetry, line of reflection, and this line connecting x to x prime? Their slopes would have to be opposite reciprocals. Alrighty? So ladies and gentlemen, we have gone through 6 different types of reflections. That's basically all of the reflections we need to know. I hope this helps. I'm going to post this answer key on Google Classroom as well as this video after you finish this Ed puzzle. Thanks, everybody.